Welcome friends, welcome back to our channel Crystal Learning. So today we will see the subject strength of materials. Question was, which one of the following is correct in respect to Poisson ratio limits for an isotropic elastic solid? Okay, this question came in Engineering Services Mechanical 2004. It is a very simple question, but few students have doubt because B option and C option. But just read out this question carefully. It is saying Poisson ratio limit for an isotropic solid. Okay, these 2 points, limits and isotropic solids. It is not saying for metals. Okay, just keep this thing in mind. So when Poisson found out that mu value is 1.4, but for in future, based on better models, mu was coming 1 by 3. So they decided a range that most of the metals were coming in this range. New value, that is Poisson ratio, was coming for most metal in this range. Most of the students are marking this question option. That is wrong because it is the range for metals. Okay, but for other materials or solids like low density open cell polymer foam, it is coming -1. So that elastic range of Poisson ratio will be in -1 to, that is, plus 0.5. That is isotropic solid. It is never says, this question never said it is asking for metals. Okay, so now the confusion is clear. Now let's see how it is coming -1 to zero point 0.5 plus 0.5. So for isotropic solid, we know this relation G equal to E divided by 2 bracket 1 plus nu. So E is for E and G has to be positive quantity because E is sigma by epsilon. So both terms are positive or both terms are negative when taken side by side, means tensile stress gives to tensile strain. Okay, this plus plus. So it will be coming always positive, this quantity E and G. So for that condition, for G to be positive, this denominator has to be positive because it is the compulsion. So 1 plus nu greater or equal to 0 or nu is greater or equal to -1. And next, this is one condition. Next condition is for volumetric strain. If there is a hydrostatic pressure minus P, then volumetric strain is the sum of three normal strains. Okay, that is epsilon V equal to epsilon X plus epsilon Y plus epsilon Z, that is P by K, and K is bulk modulus. And bulk modulus and elastic modulus relation is given by this: K equal to E 3 bracket 1 minus 2 nu. E is positive, so K will be positive. Okay, for K to be positive, K has to be positive only if E is positive and this denominator term will be positive. So K has to be positive, and why K has to be positive I will discuss little bit after this. So now this 1 minus 2 nu has to be positive. Why? Because we have to make this K positive. E is already positive. Okay, so this is greater or equal to 0 or 1 greater or equal to 2 nu, or nu is less than or equal to minus, sorry, plus half. Okay, plus half. So this relation is coming less than or equal to. So now we will discuss why this K has to be positive. What is the meaning of K to be positive? That is bulk modulus. So bulk modulus elasticity, when you study in that is fluid mechanics, the relation is given by K is given by minus V del P by del V. You can just revise this concept from fluid mechanics books. Anywhere you can find this relation. Okay. So we know that pressure and volume is inversely proportional always. Why? As pressure increases, then volume will decrease. So this dP by dV is the negative term. So this negative and this negative means positive. So K has to be always positive. So if we say if K is negative, then what that means? If K is negative, then hydrostatic pressure would cause expansion of cube of isotopic material. You are applying the hydrostatic pressure in compressive direction. Suppose this is the material. Okay, this is the material. Are you applying hydrostatic pressure from this all this direction? So if K will be negative, that means you are applying pressure in compressive direction, but volume is expanding. That is not possible. So so it is always said that volume decreases as pressure increases. For that, K has to be positive. From there, we have seen why K has to be positive. So we got the relation, that is Poisson ratio value is greater than -1 and less than half. So this has to be the answer of this question. Okay, Poisson ratio limit for hydrostatic pressure. So I hope now confusion is not there in the mind that why this B option won't be true for this option. So meet you with next lecture with the next question. Till then, have a nice day.